What's the difference between zonation and succession? That's a question that ESS, for some reason, loves to ask. I like to think of the two as having nothing to do with each other, but being confused simply because they're both words you have likely never heard of before.
So, we will try to make a system out of it so you do not mix them up. For that, we're going to use a mnemonic, so an aid to help you remember what each word stands for. Zonation looks at change over space. Remember that the zone in zonation stands for zones, and zones refer to space. Succession looks at change over time. So the S in succession we will have stand for seconds, and seconds, of course, refer to time. Or, if that does not stick, just remember that success takes time, no matter what context you look at it in. So, with those two differentiators in mind, let's look at what they actually each mean. Zonation first. The official definition is the change in community along an environmental gradient.
Let's look at the first key term here. A community is a collection of interacting populations within an ecosystem. So, in the context of zonation, we're looking at how the living community of an environment changes as you move along some kind of environmental gradient. Which brings us to our next key term. What is an environmental gradient? An environmental gradient is the gradual change in an environmental factor across space. Now, you don't need to memorize this definition, but you do need to understand what an environmental gradient is. So we're going to look at it through two examples. Example 1. Let's say you and a friend are going for a hike. At the start, you see grasslands and a mix of trees. As you climb higher, you start to notice mainly pine trees and less grass. And near the top, the grassland had almost disappeared. The ground is rocky, and the species around you are completely different. At the very top, there may even be snow, and the species you encounter have changed entirely. What you are observing is a change in community the higher you go in altitude. That makes altitude the environmental gradient in this example. Of course, it is not altitude itself that is directly changing the community. What is actually happening is that as you go higher, the abiotic factors shift, meaning it gets colder, precipitation changes, and wind may increase. Those are things that actually determine which species can survive where. So, altitude is not the cause of those changes, but it is what you are moving along as you observe those changes. In other words, the environmental gradient. Okay, let's look at a different example. You and your friend are at the beach. You get out of the car at the parking lot where you can still see trees growing. You walk towards the water, and there you see different animals, like seagulls and crabs along the shore. The community changed drastically from the parking lot to the water's edge. What you just walked along is a distance to shore gradient. You started inland and moved toward the sea, and the community shifted the closer you got. Far away from the sea, you had trees, and further toward the sea, you found other organisms, like crabs. These changes in community can be measured using a transect, which is simply a line laid out along the environmental gradient. In our beach example, that line would run from the parking lot all the way to the water's edge. Zonation can then be measured at regular intervals along that transect, meaning you can see where, along that environmental gradient, which organisms live. So, along our transect here, we have the following organisms living: crabs, seagulls, egrets, sea turtles, oyster catchers, and sycamore trees. So, using a transect, we can then record exactly where these animals live along our environmental gradient, distance to shore. Once you have collected this data, you can then plot this on a kite diagram, which you, for the exam, need to be able to read. So, this kite diagram shows the distribution of the community we just looked at. The x-axis shows the distance to shore in meters, with 3 meters being right at the shore. On the y-axis, you see the different animals listed, so those we saw in our beach example just now. We were able to see that as we get closer to the shore, so towards 3 meters away from the shore on the x-axis, different species are abundant. So, While sycamore trees in green are most abundant furthest away from shore, the crab is most abundant closest to shore from all the animals listed. A kite diagram is, in this way, an exact representation of zonation along a graph. The change in community along an environmental gradient. The community is on the y-axis, and the gradient is on the x-axis. Let's have a look at crabs. The widest point of the kite shows where the greatest number of crabs live along this transect of distance to shore. The kite is widest at around 5 meters away from the shore. Similarly, you can read where each animal is most abundant by looking at the widest point of the kite. This is how you can read a kite diagram. So now that you have understood how to interpret data from zonation, let's go over the most common examples of environmental gradients. You do not need to remember these, but I do want you to have heard of them. We have changes in elevation, which we looked at in our hiking example, changes in latitude, along which you can see the distribution of biomes, change in tidal level, which looks at increasing depth of the water as you go further out on sea, soil horizons, which means looking at how the community changes as you go deeper into the soil, and finally, distance to shore, which is what we saw in the beach example earlier. All right, so today we covered how zonation looks at change over space and went through the official definition, that zonation refers to the change in community along an environmental gradient. We also came to understand that an environmental gradient is the change in an environmental factor across space, alongside two examples, altitude and distance to shore. We then looked at how at regular intervals, data is recorded along a transect. This is done to measure the changes along an environmental gradient. And then we went through how we record the data seen on a transect on a kite diagram, with the gradient on the x-axis and the species on the y-axis. Where the kite is widest, each species is most abundant along the gradient. And lastly, because there are many examples of environmental gradients, we ran through a few more, such as altitude, latitude, tidal level, soil horizons, and distance to shore. All right, now that we've come to understand how zonation refers to changes over space, check out my next video to see how succession refers to changes over time.